Hi, my name is Eric Spengler, and I'm going to be talking about creating a site-to-site IPsec VPN connection using the command line interface. Now, there's a couple reasons why we'd want to create a site-to-site connection. Certainly, if we have two offices that are connected through a public type of network and we want to secure that information, IPsec's an ideal way to do that. And the commands required to create the site-to-site connection are fairly trivial. So what we're going to go ahead now is look at the commands, and we're going to put the commands in our environment and take a look at some of the verifications so we can see what we've done and that packets are actually being encrypted. Now, in order to create this type of connection, we have some basic tasks that have to be performed. Number one, we have to identify an item called a policy, and the policy is tied to our Phase 1 SA for IPsec. That establishes our trust relationship. So with that, we can use a pre-shared key or a certificate to form that trust relationship. Certainly you want to make sure that whoever you're encrypting data with is the person you're actually expecting to encrypt that data with. Second task we're going to be doing is creating a transform set definition. The transform set allows us to actually identify how that information is going to be encrypted, what encryption protocol is going to be used, and the size of the key that'll be utilized, as long as we have, or as well as having some hashing configurations. From there, we create what we call a map, which allows us to glue all that information together. And with that, we look at interesting traffic. In fact, what is actually going to be encrypted. So let's take a look at the configurations, and you can see they're fairly basic. You're going to see they're fairly basic. And then we'll go ahead and test and take a look at a couple of show commands. In my file right here, I've created the basic configuration for both router 1 and router 3, and they map to each other, and the objective is to create this IPsec tunnel you can see is identified here and encrypt the information between those two routers. So to start off, I of course had some basic configuration, but jumping right to the encryption configurations, I'm going to go ahead and create a policy, and you can see the policy allows me to define the use of a pre-shared key. It allows me to define AES 256-bit encryption. Again, that's used for the authentication process, not for the process of actually encrypting the data. So I have to make that very clear. And then other things such as group 5 Diffie-Hellman and a key lifetime of 3600. Now we have to make sure, certainly, that whatever we have here, we mirror on the other side. And as I scroll down and look at router 3, you can see I have the same configuration on router 3. The next item that needs to be configured is something called the key. Now, the reason I have to configure a key is because the use of the authentication pre-share command has been issued, and therefore, following that, I have to issue the key. And again, you can see it says crypto ISACAMP key Cisco 123, and the address is the address of the peer that I'm actually using that key with. And in fact, in this case, it's going to be router 3. Now, the next item I have to do, one, of course, important item you have to remember, of course, is the key has to be entered the same on both sides. And you can see I'm referencing back on router 3 the interface or the peer that key is going to be used on router 3. If the keys don't match, of course, you'll never be able to create that Phase 1 association. The next item I need to create is a transform set statement. Transform set statement allows me to identify how the traffic is actually going to be encrypted. In this case, I'm going to use encapsulating security payload, which means I'm going to encrypt the complete data packet. I'm going to be using AES 256-bit encryption, and I'm going to be using the SHA HMAC hashing algorithms. The next step is to tie it all together. Now, to tie it all together, I create what they refer to as a map. So I created a map called CMAP, and here I identify some basic things such as my peer. You can see my peer is tied back to the use of my key, which is tied back to my authentication pre-share. I identify the transform to be used, and as you can see, my transform 50 is matched. And I set up some other things such as a perfect forward secrecy using the group 5, which means I'm going to regenerate my key every so often within the timer settings. Now, the last item you see is the match, and this is very critical. Match 101. This is not an access list in the sense of blocking or filtering traffic. What this is an access list that's utilized to match traffic that will be or needs to be encrypted. So you can see I want to encrypt any data that has a source address that's prefixed by 192.168.1 and has a target or destination prefix of 192.168.3. I identify the access list, and again I put it inside my map. And if I look down at router 3, you can see from the transform set to the map, everything is virtually identical, except I'm identifying different peers. R1 is pointing to R3 and R3 is pointing to R1. The last step I have is to actually glue these to the interfaces. So in this case you can see I have serial 00, which is R1. This is my R1 interface, and I'm assigning CMAP to that interface. And down at router 3 I'm assigning CMAP, which is my definition I created here, to the serial 00, or excuse me, 011, which refers actually to the labeled 001 here. Now that I have my configurations all created, I simply need to paste those configurations in and go ahead and verify and test that they're functioning properly. So I'm going to go ahead into R1, and in R1 I'm going to paste this configuration in there. And then I'm going to go into R3, and I'm going to paste R3's configuration in. Now, once I do this, of course, I can verify that the configurations are actually included. Now you'll see the PKI certificate information, but that doesn't relate to what we're doing. That actually relates to the configuration for the SDM when I activated the HTTP security services. So there's my configuration. Now, once that's in there, of course, I simply need to look and see if my packets are being encrypted and verified. What I do is I use a command called show crypto, and this command is very extensive as far as the number of items you can control the crypto configurations and monitoring. But we're going to focus specifically on the ISACamp SA, the ISACamp SA. There we go. And you can see that I have no security association created at this point. Now, there's no security association, likely because I haven't generated any traffic yet. But I cannot encrypt packets until that association exists. And that's what my policy is designed to do, is to establish that association. Now, of course, once the association is created, I can monitor the encrypted traffic by looking at the show crypto IPsec SA. And you can see that no packets have been encrypted at this point. So let's see if we can generate some traffic and then take a look at our traffic to determine whether or not our cryptographic configurations are working properly. So I'm going to simply go to a command line and ping the other host on the other side. And I'm going to do an infinite ping. And the infinite ping will allow me to verify my security associations, and I will be sending continuous packets, so I'll be able to verify that the packet count for encryption is increasing. So again, I am actually sending packets from PCC to PCA, and if all is working correctly, I should have a ISACamp SA created, and I should be encrypting packets. So let's take a look at that. There is my ISACamp SA, and it is in fact active, which means I have a peer-to-peer IPsec session. And now I'm going to take a look at my IPsec SA, and in fact, It says I have 41 packets. As you can see, 41 packets encrypted. Now, because I have a continuous ping running, if I do it again, I should see more than 41. And in fact, now I see 52 packets being encrypted. Some of these key commands that you need to really monitor, and I think this is where people have the most difficulty, is that they forget to verify the IPsec SA, which is the phase 1 of the trust association, prior to actually looking to see whether the traffic is being encrypted or not. If you just go right to the IPsec SA without verifying the IPsec SA, then there's no likelihood that you'll really understand that the connection or the peer relationship has been established. Thank you so much.